Hello, and welcome to this Photonics Next session, 3 essential themes for riding the photonics wave. I'm Justine Murphy, Senior Editor of Laser Focus World, and it's great to have you all here. Please be aware that this presentation is being recorded and you'll be notified by email when that archive is available. You can participate today by asking questions that will be addressed during a Q&A session following this presentation. Send them at any time by simply typing into the Ask a Question window on the side of your screen and hitting Submit. We'll answer as many of those questions as possible during the Q&A session. If you have any technical difficulties during this session, just type your issue into that same Ask a Question box and our technical experts will assist you. We do recommend disabling any pop-up blocking software or extensions in your browser because sometimes these can cause issues with the webinar player. And now I'm happy to introduce our speaker, Scott Jordan, Head of Photonics at PI. Scott is a physicist who holds an MBA in finance and new ventures and has made multiple contributions in fields such as photonics alignment automation, precision motion control, and optimization technologies. Welcome, Scott. The floor is yours.
Thank you very much, and thank you, everybody, for joining us here today. As she said, the topic today is the 3 essential themes for riding the photonics wave. Let's talk about that. First, a very brief description of what my company is. We are a global company. We're headquartered in Germany. We have centers for excellence and engineers and sales experts all over the world to work on your applications and to help support you and your customers wherever they may be in the high-tech world. So we've been around for 53 years now, and that means that we have seen the rise of multiple technologies, starting with the semiconductor industry and also genomics automation and now photonics. In each of those fields, we've held a role that has been an enabling role for the scalable manufacturing of those technologies. And we're doing the same thing for photonics today. So let's talk about that. So the data trend is what is driving photonics. The fact that we are walking around with supercomputers in our pockets and consuming data and producing data, ranging from the humble selfie all the way to streaming media and social networks and you name it. And it's only increasing. As you can see, it's increased monotonically for the past, well, since the records have been kept. And that's because we are generating and consuming that data. So even in the lost year of 2020, when the pandemic was hitting the world hard, the data consumption grew by 23%. And we have no reason to expect that that will be slowing down anytime soon, because it's just the beginning. Data is part of the issue, but also the fact that more and more diverse data and more diverse applications that utilize that data, generate that data, more and more diverse sensors that produce that data. These are what we are dealing with today as an industry. It's very exciting times because it's not just about the data center anymore. That's where silicon photonics got its start, by providing faster, more capacious, and more energy efficient interconnects within the gargantuan data centers that drive the distribution of the data that we consume every day. But look at some of these new applications here. Wearable technologies to monitor your health, autonomous technologies for cars that drive themselves, such as LiDAR. What about quantum computing? That just about every type of quantum computer has a photonics element to it, and many applications are emerging for that as well. In the consumer realm, you're seeing optical cables, active optical cables, to accommodate the high frame rates and the high resolutions that and pixel counts that people want from their entertainment and gaming setups. And copper starts to run out of steam over the kind of cable lengths that people want. And what about optical computing? This is where you can perform sophisticated calculations and inferences in the time it takes a photon to traverse the width of a semiconductor chip. So this is what is going to be driving photonics in the very, very near future. The thing is, what does that mean for us as engineers and manufacturers? Take a look at this. For the data center industry, one of the biggest players is Intel. And this is one of their public slides here, and it shows an amazing accomplishment of making more than 2 million optical interconnect transceivers per year. But look at some of these other applications, hundreds of millions here, 400 million there. You add them all up, and it means that this industry must navigate a 3 order of magnitude scaling in the next several years. Now, that has profound impact on our plans. The fact that this industry needs to overcome that step function, and there's only a few ways to do it. Now, there are scripts that we can follow. If you look at what the semiconductor industry did, you'll find that automation, innovation, and cooperation were the 3 elements. Those are the 3 themes that are part of the title of this presentation here. Those 3 things are what is going to allow this industry to move forward and achieve that 3 order of magnitude leap in overall productivity. Now, as I said, the semiconductor industry showed us the way forward a long time ago. This wonderful video from the Chip History Museum is an Intel fab from the early 1980s. It wasn't that long ago. This is where the CPU for your father's or your grandfather's IBM PC was being manufactured here. That's what you see. It should look familiar. Lots of manual processing, lots of people involved. Isn't that just like photonics today? But this scene that you see here with all this custom equipment has been supplanted today. Today, you can build a fab just by issuing purchase orders because all of these tool manufacturers have emerged since the early 1980s. Now this ecosystem exists. And this is happening in photonics. It's happening before our very eyes. Now, the problem, though, if you look at an analysis of where the costs are in manufacturing a photonic device, silicon photonic device, you'll find that 80% of the cost is in the packaging, and specifically in the alignment process, which must be repeated over and over again, starting at the wafer level. When you have a wafer full of chips, whether they're electronic or photonic, you need to test them. You don't want to invest the cost of packaging a bad chip. So you need to test it to be sure the chip is good before the process begins. And because chips are easy to kill, you need to keep testing it during the assembly process to ensure that it remains functional as the process goes on. So this repetitive need that starts at the wafer level for wafer probing and continues through the packaging process, this is what drives the cost of photonic devices today. So this is why we have attacked the cost of alignment. Now, today's silicon photonic devices differ significantly from the photonic devices of, say, 1997 or 2000. They're multi-channel devices today, for one thing. So you have additional degrees of freedom involved in aligning all those multiple channels. You have a theta Z component. You have other thetas that must be correct. It isn't just in terms of transverse alignment anymore. There's also these angular degrees of freedom. The problem is that with conventional alignment technology, every time you make a small motion in theta Z, you must stop and realign in X and Y. But there is this new technology that PI developed. It was introduced in 2016, so less than a decade ago, and it won multiple awards, such as the prestigious R&D 100 award. It allows you to align simultaneously across multiple degrees of freedom, multiple inputs and outputs, multiple channels, all in one step. By doing these alignments simultaneously, we reduce the overall cost of alignment by 99%. Now, just for example, to do an alignment of an array device on a wafer can take a couple of minutes using conventional technologies. Using our technology, you could do a 6 degree of freedom alignment on both sides, input and output of these devices, in about 1 second. So that's where this 2 order of magnitude reduction in cost comes from the unique ability to align these devices simultaneously across degrees of freedom, inputs, outputs, and channels. Now, this is a technology that we have implemented across our product line. First, hexapod micro robots, which are highly stiff, highly stable, very, very rigid devices that can be mounted in any orientation and allow you to create a coordinate system wherever it makes the most sense for your application. That's very popular. And this technology is built into that, this multi-channel, multiple degree of freedom parallel alignment technology is just built into the command set of the hexapod controllers. Similarly, for our piezo devices, such as the popular nanocube, which is a 3-degree of freedom device, and now stacks of stages driven by the ACS controls. We purchased ACS, which is a very well-regarded industrial motion control manufacturer several years ago, and now this technology has come to the world of ACS controls as well. So I'd like to say a little bit more about that. This gives us the flexibility to configure the optimal solution for your particular application. For hexapods, you have this benefit of this very, very flexible path planning and compact 6-degree of freedom, very rigid structures, no moving cables. With stacks, the modularity, the long travels, and everything driven by the ACS controls. Both of these allow you to rotate about a sweet spot, to be able to define a rotational center point where it makes the most sense for your application. For example, at the input to a waveguide or at the focus of a lens. So we use piezo devices such as our nanocubes whenever there is the need for maximum speed, because piezo devices are just incredibly fast. Also, because they are flexure devices, and there is no wear, there are no lubricants. That means they can perform long-term tracking. Long-term can mean days, weeks, months, if you wish, because there's nothing to wear out in a piezo device. Similarly, same comment for air bearings. Long lifetime, zero maintenance, no lubrication, nanoscale resolution, and high dynamics. Those characteristics of both types of mechanisms. And then all of these technologies leverage proven technologies, fab class technologies. The alignment functionalities is built into the firmware, which makes it fast. And the parallel capability is absolutely unique to PI. So looking at some of the pluses and minuses here, now that we've expanded this to include our entire product line, you can see the virtual pivot point is available across all types of motion. Modularity is a strength of the mechanical stages, the stacks of stages. Speed is excellent for all of these, especially for nanocubes. Tracking, long-term tracking. All of these can do tracking in the short term. Long-term tracking, that's something that air bearings and nanopositioners can do. Resolution is best in terms of nanopositioning and air bearing devices, and the mean time between failure is obviously going to be best for those mechanisms that have no wear at all. This modular expanded capabilities, our latest effort to serve the flexible requirements. Every customer has different needs. Every application is different. And we're seeing more and more large format applications with circuit boards, trays, large substrates that alignment and characterization needs to be performed over a large area. So this allows us to do that. You can read about it. These QR codes that I show on the screen here, you can just point your phone at that and it'll take you directly to the publication or the catalog page that describes these devices. Now, one thing that we have done in the 50 some odd years of PI's existence, we have always prioritized working with the pioneers in the industries that we serve. For example, in the field of fast wafer probing, the pioneer in that field was FormFactor in 2016, showing the very first fast engineering probers that utilized this technology to revolutionize the speed and capability for testing photonic wafers. Etiplan is a tool manufacturer that makes assembly equipment that leverages this parallel technology that I've described. I had the great pleasure to play with one of their setups at the Photonic Integrated Circuit Conference just a few months ago in Brussels. Their software is amazing, and really it is not only easy to use and fast and capable, but very capable of keeping pace with your needs and your devices as they evolve. Very, very recommended. So we've taken this approach to the whole ecosystem here. We work with contract manufacturers like Averna and GES. We work with uh, systems integrators, tool manufacturers, obviously. So again, you go back to that slide that showed the little video from the Intel fab back in the 1980s. Remember, I said that ecosystem of tool manufacturers didn't exist and it evolved since the 1980s, and all of these amazing companies sprang from that foundation. The same thing is happening now in photonics. It's a beautiful thing to see. Now, one thing that we do, we recently opened what we call our tech center here in Silicon Valley. This is a space for us to work with our customers, and it's also a resource for our customers. For example, we've had customers meet with their funders here in Silicon Valley. They might not have an office of their own, so this is a place where we can help them by allowing them to use our conference rooms and our meeting spaces. So let me show you a little bit about that. Welcome to PI's Silicon Valley Technology Center. Here we address what's possible in the world of photonics today. We have a showroom with many examples of the equipment that we make. And this is the place where we have a team that can work directly with customers to solve advanced problems involving ultra-precision motion and photonic alignment. Okay, over in Europe, the phenomenon of pilot lines and consortia is one of the things that is helping drive the innovation for the photonics field and others as well. So in particular, there is the Photonics 21 initiative. It was established a decade ago, and it is what has been the motivation and significant source of funding for the pilot lines and consortia. So one of the most recent of the consortia that have been established from the Photonics 21 overall initiative is the Podium Photonics Assembly Consortium. It's established in the Netherlands, but it's a global resource for companies and enterprises who are looking for scalable approaches to packaging their photonic devices. Highly recommended. PI is one of the participants, but as you can see, there is a critical mass of participants in this consortium here. People with expertise in packaging, people with expertise in device placement and things of that sort, and automated assembly. We all work together to try to come up with solutions to tough manufacturing problems with an eye to scaling. So to summarize, well, you can see this quotation from Pat Gelsinger, currently CEO of Intel. Back in 2005, he said, optics is a niche technology, but very soon it's going to be the mainstream every chip that his company builds. And sure enough, we're starting to see that. One of the large trends in the photonics field has been this steady diminishment of link length. After all, the photonics field started back in 1997 in the first big photonics boom to replace the lengthy satellite, geosynchronous satellite connections that were the way that people made long distance phone calls at the time. Your voice would literally bounce off the satellite in geosynchronous orbit 20 some odd thousand miles away. There'd be significant delays, there was significant limits to bandwidth, and there were significant costs. Well, that was all then. Today, those satellite links have been replaced with transoceanic optical cables, and then from that, transcontinental, and then regional, metro, fiber to the home, and then the data centers. And now we're starting to see chip to chip interconnects and even chip, intra chip interconnects where things such as RAM and CPUs, GPUs are connected together using photons instead of electrons, all in the name of speed and capability and capacity and scalability. So photonics is here to stay. Photonics is diversifying rapidly. Photonics is about to scale. Get ready. So anything we can do, please get in touch. We're here to help. We're here to enable. That's what PI is all about. Thank you for your attention today.
Great. Thank you so much, Scott. And now let's move over into our Q&A. As I mentioned earlier, if you'd like to submit a question and you haven't already, just type it into that Ask a Question box and hit send. And it looks like we do already have some questions in the queue, so let's jump right in. How credible is the 3 order of magnitude step function in demand that you mentioned? Photonics had a big crash 20 years ago. Should we be concerned that that could happen again?
No, I don't think so at all. I just gave the analogy of where photonics started. It started with a single application, replacing long distance telephone connections that used expensive, low capacity geosynchronous satellites. That's where photonics, as we know today, got its start, starting around 1997. The single application, single point of failure. When you think about it, replacing those connections, those satellite connections with transoceanic, transcontinental connections, the industry did something very smart. They laid more fiber than they needed at the moment, dark fiber. And at some point, okay, that's it. They've laid all the fiber they need for a while. That's when the industry went into a very steep decline that stayed for about 10 years. Now, that's not going to happen today because of all these applications that we're talking about here, because of our appetite for data is changing the way the world works. We no longer see a single point of failure. We see instead multiple paths for demand. So I think that 3 order of magnitude scaling is very real. And I have the data to back it up. You saw it in that slide, all these projections for all these new applications. So no, we're not going to see the likes of 2002 again.
Great, that's a relief. What about systems integrators and contract manufacturers? Are they a solution for building equipment optimized for my devices and processes?
Absolutely. I mentioned a few of them. There are some out there. There are some contract manufacturers local to certain regions. There are resources like the Podium Alliance that I mentioned that can help guide you to contract manufacturers or choose tooling and a production, do the production engineering for your own fabrication facilities if you wanted. There are, well, let's put it this way, the photonics industry doesn't talk enough about contract manufacturers. I think they are one of the unspoken heroes of the photonics industry already, and they're only going to become more important as time goes on. So we know them, we talk with them, we supply them, so we can help introduce you as your needs advance.
Great. And my company has a component design, but we are unclear on the best path for ramping. What do you recommend for some first steps?
Talk to the people at Podium. They've seen it all and they have ideas. They can give you guidance. This is really something important for early in the engineering phase. It's really surprising how companies, especially young ventures, focus on the technology and the manufacturing becomes a regrettable afterthought. Um, Try to avoid that. We can help again. There was even one venture where I was invited in to provide a presentation to the investors to give them comfort that this company was paying proper attention to scalable manufacturing. So we can help you in that regards as well. But ultimately, just know that manufacturing is a very specialized field. Doing so cost effectively with good yield requires the latest technologies, and that's where we're here to help. So it starts with the conversation with PI. As you saw from my very first slide, we're all over the world. Contact your local PI office, talk to their applications engineers. Let's let the conversation get started.
Great. And unfortunately, we are just about out of time. Any questions we weren't able to get to today will be addressed directly via email. So on behalf of Laser Focus World, I'd like to thank Scott Jordan for such a great presentation, and of course, all of you too for joining us. And once we're done here, there will be a quick survey popping up. Please do share your thoughts with us because that helps guide us as we plan future Photonics Next content. And don't miss our next session, Next Gen Laser Analysis Solutions. You can join that by simply exiting out of this event and going back into today's agenda. Thank you again to Scott Jordan and all of you for attending.
Thank you.